Hello, welcome to our 6.5 video. I have shifted gears a little bit, and this video was uploaded on Canvas, and the questions will be asked on Canvas. Um, there were some glitches that people were experiencing with an item pool. It was worth a shot, and I kind of like it, but I found a way to do it through Canvas. It has some limitations and some benefits. So we're feeling things out, but thank you for watching. So let's take a look at 6.5. Let's remind ourselves about some of the basics of sine, cosine, and tangent, okay? SOHCAHTOA, as I've said in class, SOHCAHTOA. Now, I know that's not a real word, but it kind of sounds funny, right? It sounds like suck a toe. So the so part is opposite over hypotenuse for tangent, adjacent over hypotenuse for cosine, and opposite over adjacent for tangent. And when we say opposite, adjacent, and hypotenuse, what are we talking about? Well, we're talking about angle A specifically here, right? So here's angle A. Remember that the right angle, I know it's not drawn in this particular picture, but that right angle points towards the hypotenuse. And then across the triangle is the opposite side. And then the side right next to it is the adjacent side. Okay? And let's answer this question off to the side. How will the ratios change if you use angle B as your reference angle? Well, let me redraw the triangle a little smaller here so that way it fits. Maybe a little smaller here so that way it fits. It hates me. Okay, I wouldn't want to click into place there. But here's angle B. This side is now the opposite. This side is now the adjacent, and this is the hypotenuse. Okay, so it ends up getting flip-flopped. It ends up getting flip-flopped for angle B, right? The sine of A is cosine of B, and the cosine of A is the sine of B. You remember how that flip-flopped? We'll see it in action here. But because these two roles switched, sine and cosine are switching. And tangent of A and tangent of B are reciprocals. Okay? Let's see this in action here. Let's solve for a side. We're going to break out our calculators today. We're going to have to break out our calculators. And actually, let me prepare my calculator on my end. Sorry, I probably should have had this ready. You can fast forward me for like 2 seconds. So there's my calculator. And now back to the notes. So take note of where the angle is. Okay. Which side is x? X is the opposite side. The arrow points towards the hypotenuse, and 11 is the adjacent side. And we're going to solve for x. Okay. We're going to solve for the opposite side. This is a right triangle, and you might be tempted to say, well, can't we just use the Pythagorean theorem? We only know one side. That's a pretty big issue, right? I need to know 2 out of the 3 sides to use the Pythagorean theorem. So we're going to use trig functions. Which trig function should we use? We're trying to solve for the opposite side, and we know the adjacent side. What does that mean we should use? Tangent. Tangent is opposite over adjacent. So we're trying to solve for the opposite side, and we know the adjacent side. So we're going to use tangent to solve. Check this out. Tangent of 28 degrees is equal to opposite over adjacent. Yeah? Opposite over adjacent, just like that. And how are we going to get rid of this 11? If I'm trying to solve for x, how do we get rid of it? If we're dividing by 11, we're going to multiply by 11 to each side. So 11 times tangent of 28 degrees equals x. And this right here, we plug into our calculator. Okay? So I'm using the Google calculator. You want to make sure you're in degree mode. You see that right there, how I clicked DEG? We're in degree mode. So 11 times tangent of 28 degrees is 5.8. 5.8. Let's do it again. So what angle are we given? We're given this guy right here. And we're trying to solve for the opposite side. And we know the hypotenuse. So which trig function should we use? Sine, because that's opposite over hypotenuse. Sine of 40 degrees is equal to what? Opposite over hypotenuse. We don't know the opposite side, but we know the hypotenuse. And how do we solve for x? We simply multiply by 10 to cancel that out. So 10 times sine of 40 degrees equals x. So x is equal to, back to the calculator, 10 times sine of 40. 6.4. Okay. So get ready for a question here. Let's label this together, and then you're going to tell me which trig function we should use. Sine, cosine, or tangent. All right. Here's 68 degrees. 7 is, think about it. This isn't the question yet, but is it opposite, adjacent, or hypotenuse? It's the opposite side. And x is the hypotenuse. So tell me, which trig function should we use? Insert question here. So this guy, we have a question on. What is it? What did you just answer? The answer is sine. Once again, right? Sine is opposite over hypotenuse. So sine, let me go back to black here. Sine of 68 degrees is equal to opposite over hypotenuse. Now, something different is happening in this example. You see how x is on the bottom as opposed to the top? So how do we get it out of the bottom, right? How do we get it out from the denominator? Well, we're going to imagine this is a fraction, right? Imagine that as a fraction, and let's cross multiply to get it out of the denominator. Does that make sense, right? I don't want to solve for x in the denominator. I just want x. So if we cross multiply, we end up with x times sine of 68 degrees equals, well, 1 times 7, that's just 7. So we cross multiplied. This times this equals this times this. And now x is out of the denominator, and so we're going to divide this away to cancel that out. So x equals 7 divided by sine of 68. And you plug that into a calculator. Now, I know some students get a little intimidated by that, right? You might have been like, whoa, what did we just do? I want you to think this is just a number. This is just a number. What if I gave you 2 equals 7 over x? I hope you would be comfortable with this. I hope that you would be comfortable with that. That's the exact same thing that I just did over here. It's just that instead of that being a measly little 2, it was sine of 68 the entire time. Okay? It's just a number. Even though it's a big, messy expression, it's just a number. okay? And we let our calculator do the work. So 7 divided by sine of 68 degrees is 7.5. Okay? Let's keep going. Let's keep rolling with the examples. I think the more examples, the better here. So let's go a little bit quicker so that way this video isn't too long. This is the angle. X is the adjacent side, and this is the hypotenuse. So what function are we going to use? Cosine. So cosine of 21 degrees equals adjacent over hypotenuse. How about you take a second to solve that one and plug it into your calculator? Boom. Question should be popping up on screen. All you have to do is multiply by 7 to each side to cancel that out, and now you've just got x. So whatever that is plugged into a calculator is, boom, your answer. And you should have plugged it in by now, and you already answered. The answer is 7 times cosine of 21, 6.5. Maybe we don't do all of them just for the sake of time. Let's do D. I mean, we've nearly done all of them, but maybe one less will save us a little bit of time. This is the opposite side. This is the adjacent side. So boom, we're using tangent. Tangent of 30 degrees equals opposite over adjacent. And I wrote A, but I guess I meant X, right? And then, okay, here's another moment where X is in the denominator. So it becomes a cross multiplication. The only reason I'm cross multiplying is so that way I can get X out of the denominator. I don't like it there. You know what I'm saying? It's buried down there. That's not what we want. Okay? So then we divide by tangent of 30. X equals 7 divided by tangent of 30 degrees. Holy cow, though. You know what I just realized? Though? It's 30 degrees. Guess what, guys? This is a 30, 60, 90 triangle. We just had our quiz on that. We know X right away. What does X equal? That's the long leg. How do you go from the short leg to the long leg? You multiply by the square root of 3. So that's 7 root 3. You ready to have your mind blown? Are you ready to have your mind blown? Let's plug in 7 root 3 into a calculator. 7 times the square root of 3. There's a decimal answer, right? Are you ready for this? When I plug in 7 divided by tangent of 30, which is what I did when I did the work by hand, 7 divided by tangent of 30. Boom. Same thing. I hope you're impressed. All right. Let's keep it going. A little more spice of life here. We've got like a couple triangles merged together, and then we have like one big overarching triangle that makes up the whole thing. Find the length of the side labeled X. Round intermediate values to the nearest tenth. That word intermediate will make sense here in a second. Use the rounded values to calculate the next value. Round your final answer to the nearest tenth. So, do we have enough information to solve for X? Well, if you just look at this triangle, we don't know anything about that triangle. So I'm literally clueless. There is not enough information when I look at that purple triangle. However, if I say, well, wait a minute, there's another triangle right next to it, maybe I can figure out this side first and then use that side to solve for X. So that is our intermediate value. Okay, so how do we solve for that red side? Well, that is the opposite side of 34 degrees, and this is the hypotenuse. So sine SOHCAHTOA, sine of 34 degrees equals opposite. We don't know it. I'm just going to call it O. because I don't want to confuse it with the x that we're actually solving for, over hypotenuse. And then you multiply by 41, of course, to cancel that out. So this is the same thing that we were just doing. I'm not going to switch screens. I'm just simply going to type this into a calculator real quick. And I got 22.9 for O, for this side right here. Okay, so let's have another question right here. Tell me, that just to keep you on your toes here, I'm not even going to label anything. Just tell me, function am I about to use to solve for x? We now know this red side, and we're trying to solve for x. What function am I about to use? So I didn't pre-label anything. I'll label it for you now, because now that you've answered, this is the opposite side, and this side is now the adjacent side to 48. So we're going to use tangent. Tangent of 48 degrees is x over, and we just solved for it, 22.9. Multiply by 22.9 to get rid of it. So x equals 22.9 times tangent of 48 degrees. And you know what? How about we have double questions right here? Plug this into a calculator for me. Boom. All right, you just plugged it in. I'm going to go ahead and type it in. 22.9 times tangent of 48 is 25.4. We're getting a little bit on the long side for this video. I don't want to make it too long. I don't like when it's like well over 20 minutes. So let's jump into the word problems, okay? It's very repetitive though. There's nothing particularly new about these problems compared to these. These, it was just boom, plastered on the page, already drawn for you, perfect, right? Now you kind of have to decipher a couple of words, but just remember, it's all about a triangle, a right triangle, and figuring out what the opposite, adjacent, and hypotenuse is. So this is pre-drawn for us, this loading dock here. A loading dock at a factory has a 16-foot long ramp in front of it. So here's our beautiful 16-foot long ramp, as shown in the figure. The ramp makes an 8-degree angle, so beautiful, there's our 8-degree angle. To the nearest tenth of a foot, what is the height of the loading dock? And how far does the ramp extend in front of the loading dock? So we have two answers. So we are trying to solve for the opposite side and the adjacent side. And this right here is the hypotenuse. We solve them one at a time. Let's solve for the opposite side first. We know we're trying to solve for the opposite side, and we know the hypotenuse. What function do we use? O and H? SOHCAHTOA. Sine is opposite over hypotenuse. So sine of 8 degrees is equal to the y value, that opposite side, over hypotenuse. So sine of 8 degrees equals y over 16. Multiply by 16. Plug that into a calculator. And I get 2.2. And I guess we're dealing with feet. So 2.2 feet when I plug that into a calculator. So if we're trying to solve for x, that's the adjacent side. So we are trying to solve for the adjacent side, and we know the hypotenuse. Adjacent and hypotenuse, cosine. Plug that into a calculator. Again, I don't really see a point to keep showing you my calculator, so I'm just going to plug it in real quick. 15.8 feet. Now, you might be asking, well, could I have used this value? Yes, you could have, but I wouldn't suggest it. Why? Because what if you got it wrong? What if you did it wrong, right? At least you know 16 is true, right? But if you turn around and use a wrong number to solve for the next number, you're screwed, right? Here we had to use a number that we solved for in order to figure out the next number. Here you don't have to. So if you don't have to, I wouldn't do it. That's my suggestion. Let's keep it going. Let's jump around to example 5. We'll do maybe 1 or 2 more. We'll see what time stamp we're at here when I lift my head up here. So a building is 60 feet high. Okay, beautiful. Labeled. We have a drawing already. From a distance, point A on the ground, the angle of elevation to the top of the building is 40 degrees. So from a distant point on the ground, the angle up to the top of the building is 40 degrees. So that's what's being depicted there. Okay. From a little nearer, all right, here's point B. The angle of elevation is 70. And I hope that makes sense, right? If you're really far away from, say, the Statue of Liberty and you look at it, you barely have to look up. It's just like on the horizon, right? But if you get really close to the Statue of Liberty, you have to look up at it, right? I don't know if any of you have been to Statue of Liberty, just randomly came to mind, but right, that makes sense. So that's why the angle of elevation is higher. We want to find the distance from point A to point B. Cheeky, eh? We're trying to find that distance. Well, this right here, let me do this dark blue. This triangle right here is not a right triangle. We cannot use that triangle. We can use this triangle, which is the 70 right here, or we can use this triangle, which is the 40 here, okay? Those are the two triangles that we can solve. So we can solve for this right here would be x, and then this right here is d, right? You see how I'm seeing those two triangles, how I separated them? So if we're trying to figure out the distance from A to B, well, if we can find D and we subtract X, we'll be left with A to B, right? Take this whole distance, subtract away X, we're going to be left with A to B. So basically, we want to solve these two triangles for X and for D. So it's basically the same problem 2 times over, one with a 40-degree angle and one with a 70-degree angle. 60 is opposite of 70 and X is adjacent. 60 is opposite of 40 and D is adjacent. So we're doing tangent both times. So tangent of 70 equals 60 over X, and tangent of 40 equals 60 over, what's the letter? D. Let's do it. Cross multiply. Cross multiplying. I'm going to solve them simultaneously. And now, what do we do to get X on its own? We divide it away. You're not just dividing by 70. You're literally dividing by tangent of 70, right? You got to write that whole thing down. So let's plug these both in. I'll switch so you can see it. 60 divided by tangent of 70 is 21.8, and 60 divided by tangent of 40 is 71.5. So, like I said, we have the big distance. We know the big distance, and we know that smaller distance. So if you get rid of that small distance, we're left with the gap from A to B. So let's go ahead and plug that in 71.5 minus 21.8, we're left with 49.7 feet. Beautiful. All right. That's the 25-minute mark. Let's do one more where we have to draw a picture. We really need to see one more where we have to draw a picture. But it'll be quick. So, a boy flying a kite lets out 300 feet. So here's the boy holding a kite. It's going up into the air, right? Draw a realistic situation, okay? Don't overcomplicate it. There's our pretty kite up in the air. He lets it out 300 feet. Holy cow, he's got 300 feet of kite string, right? He's got 300 feet of kite string. So it's really up there. And he's making an angle of 38 degrees, right? So he's on the ground and he's making an angle of 38 degrees. It's extending outwards, right? We're describing real life here. Don't overcomplicate the drawing, okay? Assuming that the string is straight, how high above the ground is the kite? Okay. How high above is it, right? The kite or the string is 300, the height is unknown, but we're creating an angle of 38 degrees. And boom. Without really any suggestions or inspirations, how about you try solving it for me one more time here and just give it a shot. Give it a shot. Okay, so hopefully you gave it a shot. You should have said, okay, this is the opposite side and this is the hypotenuse. Maybe I shouldn't call this h anymore. Let's call it I don't know. Let's call it x, I guess. The height is x. So, sine of 38 degrees. Why sine? Because it's opposite and hypotenuse. X over 300. You multiply by 300 to cancel it out. And you plug that into a calculator. And it tells you the magical answer. One more time, I'll show my calculator. 100 times sine of 38. 61.5. Oh, that 6 rounds that 5 up to a 6. 61.6 feet above the ground. Lovely. And with that, we'll call it there. If you want to see some more examples, we have 1, 2, 3 more blank examples that maybe we can do during class potentially. Thank you for watching. Thanks for answering the questions. And I hope you're having or had a great weekend. All right. Thank you.